All right, we're going to do 6-1. This is my second attempt at recording. The last time the sound didn't work, so hopefully it will this time. We'll try to record this one a little bit faster too, so we can get her done. So 6-1 is all about what a radian measure is. So this idea that there's another measurement tool to measure an angle instead of just using our degree measurement, which is what we've been using for the triangle. So in chapter 6, we start talking about what a radian is, which is basically an arc length equal to the radius of a circle. So when we talk about a radian, comes from the word radius, the arc length is equal to the radius of a circle. So if you take a radius, whatever your circle is, and you measure that same distance along the edge of the circle, so say take a string and cut it to the length of the radius and then lay that string out on the arc of the circle, they would be exactly the same length. That's what a radian is. So a radian is the arc length that's equal to the radius of a circle. And arc length, remember, is just a piece of that entire distance around the circle. And if you remember from geometry, what is the entire distance around a circle called? That would be the circumference. So we're going to talk a little bit more about circumference in just a second. So if you could take a protractor and measure this angle, when we do an activity in class to talk about this, the Smarties lab, and I know you're not going to be able to do that, but this is part of what we do. We measure that angle, and if you look on mine, it's somewhere between 57 and 58. And if you can actually measure it perfectly, it would be 57.3 degrees, and we're going to talk about why that is in just a second. So it's going to be about 57.3. Now let's go and talk a little bit about circumference here for a second. So the formula for circumference back from geometry is 2 times pi times the radius. Now what we're doing is something called a unit circle. In a unit circle, our radius is just one unit. That's what we were talking about before. So our distance along here, our 1 radian, would be equal to that length of that circle. So our 1 radius this way is equal to 1 radian that way. So when we plug that into our formula for the whole circle then, if I wanted to figure out what all the way around would be, plug in 1 for my radius, that means my circumference would be 2 pi, and then the units I would use would be radians. So 2 pi is the equivalent to all the way around the circle. So 2 pi radians. So what would that mean for halfway around the circle then? If I just did half of the circle, that would be half of 2 pi, or just pi radians. So when we start thinking about how do we draw these pictures, if you were in class for the Smarties lab, what you have seen is that if we keep going with this 57.3 and measure another arc of that same amount and another arc of that same amount, what you end up getting is about 3 of those arcs and a little bit left over. And the number that's a little bit more than 3 in mathematics is pi, 3.14. That's where that's coming from. So that pi radians, there'd be about 3 arcs halfway around. That means all the way around, there'd be a little bit more than 6, which is exactly what 2 pi is. It's about 6.28. So when we think about it as a decimal number, kind of makes sense with what our picture is saying. All right, so we have 2 different measurement systems then that we can talk about. We know all the way around the circle in degrees is 360, and all the way around the circle in pi lingo, in radians, is 2 pi. Halfway around the circle is 180 degrees. Halfway around the circle then in radians would be pi, and that's where our conversion factor comes from. 180 degrees is equivalent to pi. So if you want to convert from one unit to the other, we just need our conversion factor. So if you want to go from degrees to radians, you're going to multiply by your conversion factor of pi radians to 180 degrees. Just like going from miles per hour to feet per second, you're going to have to multiply by your conversion factors. Going the other direction, we're going to multiply by, we're going to degrees, 180 over pi. So we can go both directions. So when we're doing our conversions, we just need to go back and forth and see what that would be in radians. Now, we're going to do that then for our special values. So we have our special value angles that we talk about. So we're going to do that conversion for each of them, and we'll talk about what's similar about all these. So all of them that have the 30-degree reference angle or whatever are going to have the same values. So we'll talk about those as we go through. So the first row in the chart is degrees, and the bottom row is for our radian measure. So we'll kind of go the long way, and then we'll talk about strategies as well, and I'll probably have you fill some in to make this a little bit shorter here. So 0 degrees, that's going to be 0 radians. You haven't moved. The arc length would be nothing. When you do 30, we're going to multiply by pi over 180. and we're going to reduce that fraction. So I want it in terms of pi. So 30 divides into 180 6 times. So that means that would be equivalent to pi over 6 radians. So this special value reference angle, 30 degrees, is equivalent to pi over 6. So think about it this way. 30 is 1/6 of 180. Pi over 6 is 1/6 of pi. It's representing the same amount of the circle. So when you look at the picture, it's representing the same amount of stuff. It's the same location. If you type in pi over 6 on your calculator, so actually get the decimal for it, so do like 3.14 divided by 6, check that, you get about 0.5. And if you think about it, if we'll go back to our picture here, I said that 1 radian was about 57 degrees. We'll talk about why that is here in a sec. But 1 radian being about 57, then that's almost 60, so let's just call it 60. 30 degrees then should be half as big as that, because 30 degrees is half as big as 60. So the radian measure should be half as much as what that radian measure was. So that radian measure was 1, so this one being about 0.5 makes sense. So let's go back really quick and talk about that. Why is this 57.3? Take 180 degrees divided by that pi conversion factor. So 180 divided by pi, 1 radian, that's equivalent to that 57.3 degrees. That's where it's coming from. So that's how many degrees there are per 1 radian when you break it down to that base unit. Okay, so let's keep going with this. So all of the base units are going to be these first 4. So we'll talk about reference angle here in a second for the other ones, but let's do 45. So 45 degrees times pi over 180. How many 45s are there in 180? Well, if we reduce, there would be 4 of them. So that would be 1 pi over 4, or pi over 4. Or 45 degrees is 1/4 of 180, so it's 1/4 of pi as well. And then how about 60 degrees? 60 times pi over 180. We're going to reduce, so 60 pi over 180. How many 60 degrees intervals are there in 180? There would be 3 of them, so this would be a pi over 3. So we have pi over 4, and then now pi over 3. So 60 degrees, you would need 3 of them to make 180, or it's 1/3 of 180. Excuse me, that means it would be 1/3 of pi as well. All right, last one of our reference angles here, we'll go to 90 degrees. So these first ones are our reference angles. 90 times pi over 180. How many 90 degrees intervals do you need to make 180? Well, 2 of them. So it'd be pi over 2. So pi over 2, let's do this in a different color here. We'll make these black. Pi over 2. All right, so 90 degrees is halfway to 180, so it's halfway to pi as well. Now anything that has the same reference angle is going to have the same reference angle in radians as well. So all those ones that you highlighted on your unit circle, you're going to have those same values going around the circle. So let's take a look at your unit circle for a second. I'd like you to go ahead and fill in the pi over 6, the pi over 4, the pi over 3, and the pi over 2 in your quadrant 1. So that other little line, go ahead and fill those in. So anything now in the other quadrants that you highlighted that have the same reference angle are also going to be a multiple of either pi over 6, pi over 4, pi over 3, or pi over 2. So when we go back to our chart, we can kind of match those up. So all the 30-degree reference angles, I'm going to go ahead and put those in blue here. So 210 and also 330. Every one of these is going to be some multiple of pi over 6. So let's try 150. So 150 times pi over 180. When I reduce that, how many 30s do you need to make 150? Well, 5 of them. 6 of them there. So this would be 5 pi over 6. Or it's 5/6 of the way to pi, just like 150 is 5/6 of the way to 180. So we have that base unit of pi over 6. 210, hopefully we can start weaning ourselves off the actual multiplication here. How many 7s, or I just told you, how many 30s do you need to make 210? Well, that would be 7. So this one would be 7 pi over 6. Think about it, you're a little bit more than halfway. You're 1 30-degree interval past 180. You're 1 pi over 6 then past 180 as well. And we can do our last one for the 30s. 330 times pi over 180. How many 30s do we need to divide into 330? That would be 11, so this one would be 11 pi over 6. So again, if we went 1 further, we'd be at 360. 1 interval of pi over 6 further would be 12 pi over 6, which reduces down to 2 pi. So I'm going to go ahead and fill that in. We knew that all the way around the circle was 2 pi, but that's where you get to it from the 30s. So any multiple of 30 is just a multiple of pi over 6. It works the same way. Okay, let's do our 45s. So those for me are in, let's see, green it looks like. So let's do those in green. All of the ones that are 45-degree intervals or reference angles are all going to be multiples of pi over 4. So they're going to be something pi over 4. So 135 times pi over 180. When I reduce, how many 45s do I need to make 135? Well, that'd be 3. So this one would be 3 pi over 4, or 3/4 of the way to 180, 3/4 of the way to pi. 225 would be how many 45s to make 225? Well, that would be 5 of them. So this would be 5 pi over 4. You're 1 past 180, so more than a whole, more than halfway around the circle. And then 315 times pi over 180. We know it's a multiple of 45. How many 45s to make 315? Well, you need 7 of them. So that would be 7 pi over 4. Because again, one more 45-degree interval would get you to 360. One more pi over 4 would get you to 8 pi over 4. And again, 8 pi over 4 would be 2 pi or all the way around. Okay, couple left here to do. Let's do our 60-degree reference angles. Those are in red on my picture. So 120 and 240 and 300, all the ones you highlighted before, are all going to be multiples of pi over 3. So let's take a look at 120. How many 60 degrees intervals do you need to make 120? Well, 2 of them. So that would be 2 pi over 3, or you're 2/3 of the way to 180. You're 2/3 of the way to pi. All right, 240 times pi over 180. All right, well, how many 60-degree intervals do you need to make 240? Well, 4 of them. So that would be 4 pi over 3. So you're 1 60-degree interval past 180. All right, and then the last one of these, 300 times pi over 180. You can always do it the long way if you need to. Think about how many 60s do you need to make 300? That would be 5, so we'd have 5 pi over 3. So all of the 60-degree reference angles are all going to be multiples of pi over 3. And again, we're just thinking about how many of those intervals do we need to make that angle. Okay, the last ones, we did 90 already. That was pi over 2. 180 is our conversion unit of pi. We know that one. Let's do 270. So 270 times pi over 180. We reduce that fraction. How many 90s fit into 270? That would be 3 over 2. So this one would be 3 pi over 2. So our 270 would be 3 pi over 2. 360 is 2 pi all the way around the circle. So what I need you to do is go ahead and fill in your unit circle now with all of those values. So fill in all of the reference angles in radian measures. So our goal right now is to be able to tell, okay, what is it in degrees? What does that mean in radians as an arc length, as a distance around the circle? So a radian is an arc length that's equal to the radius of the circle. Now, obviously, this works for angles even if they're not special values, and then that's just where we're going to need our calculator. We're actually going to multiply by 180 over pi or pi over 180 to convert back and forth.